In this video, I'm going to give an overview of the Flexxbotics Studio and some of the developer capabilities you can use to enable your factory automation, machines, and processes. In addition to making all types of plant equipment communicate interoperably, it can be used to get data from multiple sources for things like process control in automated operations, as well as combining it so you have contextualized data sets for AI training. So let's take a look. If I go to this top menu here, we have a couple of options. We have advanced and we have devices and transformers. Devices and transformers is where you actually define the devices for the equipment that is in the work cell. So you can see here we have Vanek robot, a Modig CNC, we have a Hexagon Global CMM, and this is where you can basically map that piece of equipment to a particular transformer and then configure that transformer with some of the metadata that it's needed to connect to it. So for example, like an IP address and a port, and then from there you can save this if you were to make any changes. The great part about the Studio editor is that it's all native Python. So what this enables users to do is leverage their own AI models in order to help inform the development of these transformers. If you were to, say, write a transformer for a particular piece of equipment, you could do things like upload the user manual for that equipment. You could do things like perform widespread searches of forums, as well as other types of open projects that have been completed for that equipment. And utilizing the template that is provided through Flex Studio, you can have AI actually develop the methods to be able to communicate via FlexxCORE to these pieces of equipment, utilizing that vast data that is available through these AI tools. Flexxbotics is a bring your own model implementation. So that means it works with ChatGPT, Cursor, Anthropic, and all of the major LLM players to do this development. And that's how we at Flexxbotics do implementations today. In this environment, this studio environment that allows for this real-time development, alongside the ability to natively do the controls within Python and pair that with an LLM, can speed up the development time of a transformer 20x. And that's why it's important facet to the ever-growing implementations that automation is going to have moving into the future. The power of the actual platform that enables an engineer to solve use cases across their entire factory. It's not black box software that you put some inputs in and there's some outputs that come out. You're defining exactly what your autonomous process is doing, and you're utilizing the power of FlexxCORE, its API, its methods, its script implementations, its data models. To actually retrieve transformers, we have what's called a studio editor. So within the studio editor, we have transformers. So transformers can be imported from our open source GitHub repository. So the repository actually maps directly to the software. And you can actually use this to import transformers, directly into the process. So within the studio environment, you have the complete ability to create new transformers as well as extend existing transformers. So a transformer is essentially a Python implementation. This is derived from a set of abstractions that are from the Flexxbotics software, and it allows you to extend the implementations. The implementation of each of these transformers is directly mapped to a FlexxCORE API that can be used to talk between devices, as well as from other external clients to those devices, as well as from autonomous scripts, and other pieces of software that are, doing things like I was showing before with the autonomous process control implementation. All of these methods here, you can see execute command V2, as I scroll down, I'll get to another one. Yeah, read interval data. These all map to read status. These all map to the FlexxCORE API. So these are the actual defined method sets for a particular implementation of a transformer. And this is consistent across all transformers. It's a standardized way to communicate to, thousands of different pieces of equipment. So you can see here we have parameter writing, parameter reading, variable writing, variable reading, status implementation, polling capabilities, file capabilities. These are all essentially canned methods that can be used as part of FlexXbotics software. You may be wondering, I want to develop a transformer. What are some of the tools that FlexXbotics can give to help with that? So the first main one is that we have complete IntelliSense capability. So there are a set of kind of core protocols and core services that are used to help with the implementation of transformers. And this is all built into the product by what we call IntelliSense. So you can see here, if I need to call particular methods that are part of the method set that FlexXbotics provides, it gives me a direct prompt to be able to do so. The other thing that this provides is a full syntax checker. So I can check my syntax of my files. It will tell me whether or not they're okay. And I can also save these files. And by saving them, I'm actually reinstantiating them into the runtime in real time. And this is really important because it can speed up the development process to make connectors to machines significantly. So if I go to this statement over here called view log, I can actually see in real time the impact that my changes are having. And when I make another change, it's going to revalidate that against the machines and give me feedback right away as to what I might need to change. Versus a typical method of developing connectors would involve recompiling, probably writing the software in some kind of offline editor where I then need to transfer files over to my machine. This can all be done directly at the machine and in real time to help speed up that process. When I click save, this is reloading the FANUC driver in real time. So if I was developing a transformer for FANUC, which in this case we would be extending the one that's already available on the open source repo, I can actually make changes and it will automatically in real time respin that and allow you to validate that change. So this is a huge advantage to using the software. The other tool that the FlexxBotics software helps with transformer development with is the FlexxCORE API view. So you can actually go here to the help menu and you can open up what's called an API test bench. What the API test bench is, it basically outlines the entire API. So we were talking significantly here about devices, and the ability to interact with devices and develop transformers that are instantiated onto devices. Well, you can interact with those devices as they're connected via this API. So you can validate that, say, a particular transformer method is working, and then you can also use this to inform when you actually go to develop the automation process, you're actually going to use these endpoints to do that. So this gives you a really nice summarized view. It also explains within a particular section of the API. It explains exactly what this does, as well as gives you a live environment to try it out and do the testing from. Yeah, so you can see the API here is very extensive. It not only covers devices and the ability to deploy transformers and test transformers for interoperability, but it also gives you the ability to automate all aspects of the process. So it's giving you the ability to talk to the part characteristics. It's giving you the ability to talk with the digital representation of the cell. It's giving you the ability to manipulate files. It's giving you the ability to generate alarms. All of this is at the hands of the developer or the controls engineer who is using the software to implement the automation within the work cell. Scripts are used to bring the capabilities of transformers together in order to actually use it within an application. So for example, you'll have machines, you'll have inspection equipment, you'll have cameras, you'll have robots, and all of these pieces of equipment need to operate together in order to perform autonomous tasks. So that's what scripts are used for within the FlexxBotics software. Scripts allow you to create references to those transformers and pieces of equipment, and they also provide a means of communicating interoperably between all of those pieces of equipment. So there are elements such as a FlexxCORE client. So this is an actual piece of software that engineers can use to talk broadly to the FlexxCORE API. There are Flex GUI pieces of software. So this allows you to extend the user interface that you're seeing here for the operator to actually provide them your own tailored and configured workflows via the Studio editor. And then there's also what we call autonomous workflows, where you can actually develop an autonomous loop directly within the Flexxbotics software and deploy that continuously. So rather than having to implement automation technology outside of the environment, you can actually automate directly within the same environment that you're using to communicate with your pieces of equipment via transformers. Scripts get deployed via the HMI. So within the advanced tab of the HMI, you can create methods to call scripts. So if I click new here on an HMI control and I want to say deploy my autonomous offset script, I can create a control within the Flexxbotics software called autonomous offsets, and I can assign this various parameters such as, where do I want it to appear on the screen? I could also make this, a different tab by just very simply typing. So now I have 4 different tabs when I did that. Say I want to put it on the operator tab. I can assign this to appear on a particular device's screen. I can assign permissions for this. So if I don't want everybody to be able to have access to this control, I can give it to just administration. I can give it to maintenance. I can give it to engineering. I can give it to technicians, or I can give it to operators. And then I can also add this to the panel, as well as enable it with intelligent recovery. To invoke a script, you use what we call commands. So commands are generic ways to both talk to the FlexxCORE API. As you can see here, I can select API as my command type, and I can select any of the endpoints that are available within the API that we showed in the API test bench earlier. I can also filter to make things easier. So say I just want to be able to interact with a device, I can select that and it will give me the available ways to communicate with that particular device. But it can also be used to generically run scripts. So I can select the command type script. I can go here and I can select the script that I want to run. And now it will be assigned to this autonomous offsets control to be able to be run. These scripts can be run in the background. So the Flexxbotics software has full multi-threading capability. So you can be deploying multiple scripts, having multiple threaded scripts running to perform various automation tasks within the cell. To finalize this, I can, give it a command name, but all of this is configurable for your particular application. You can use this advanced tab to also sequence multiple commands back to back. So say I want to run this script and then I want to communicate with a device, I can set up my control to be able to do that. So you can think of this as the higher level control that can be used to actually deploy the various automation that is embedded in transformers and scripts. You can use this to actually deploy that. And the transformers and scripts themselves is where you can leverage the open source project to get started, as well as build your own transformers that address the details of the implementation of an application. And we encourage people to contribute back to the project. However, you don't have to. Test command sequence allows you to run the command outside of the control panel. So for example, I have run APC. This is on the operator tab, but I can click test command sequence, and this will actually tell me whether or not that command succeeds. So it's just meant to be an easy way to test whether or not your command sequence works. prior to deploying it into the active controls for the cell. In this case, this is a control that is being added to the operator panel. So you can see this when I go to the control panel to the operator tab. Run APC is an active control on this screen now. Thanks for watching this overview on the Flexxbotics Studio. If you like what you saw, you can get the full Flexxbotics software download for free at flexxbotics.com/download. And be sure to check out our Flexxbotics Transformer open source project on GitHub. There's also a developer guide with helpful instructions and examples on our website. And follow Flexxbotics for more overviews, tips and tricks, and to find out about new software download releases and documentation.